Greetings to everybody. In this video, we are going to see about preparation of alkanes. Preparation of alkanes. The first method is by the hydrogenation of unsaturated hydrocarbons. What is meant by unsaturated hydrocarbons? In the previous video, we saw about what is meant by unsaturated hydrocarbons and what is meant by saturated hydrocarbons. What is meant by unsaturated hydrocarbons? The hydrocarbons which having double bond or multiple bond. Either it may be double bond or triple bond are called as unsaturated hydrocarbons. Saturated hydrocarbons means single bond. So here unsaturated hydrocarbons are converted to saturated hydrocarbon by the addition of hydrogen. That is called as hydrogenation. The process of addition of hydrogen is called as hydrogenation. Here alkene is taken or CH double bond CH2 when reacts with hydrogen, a molecule of hydrogen, two hydrogen atoms. One hydrogen atom is added to this carbon, another hydrogen is added to this carbon in presence of nickel or platinum or palladium as a catalyst at 523 to 573 Kelvin temperature. Alkane is obtained. One hydrogen atom is added to this carbon, so CH becomes CH2. Another hydrogen atom is added to this carbon, so CH2 becomes CH3. Alkene is converted into alkane. For example, ethene. Ethene means two carbon atoms, so that called as ethane. Since there is a presence of double bond, ane is pronounced as ene. So ethene reacts with a hydrogen molecule. One hydrogen atom is added here, another hydrogen atom is added here. So CH3 single bond CH3. The double bond is converted into single bond. And in the presence of nickel or platinum or palladium as a catalyst at 523 to 573 Kelvin temperature. Ethene is converted into ethane. Next, alkyne. What is meant by alkyne? Triple bond. Here or C triple bond CH. When it undergoes hydrogenation, means addition of hydrogen in presence of nickel or platinum or palladium as a catalyst at 523 to 573 Kelvin temperature. What happens? Here two molecules of hydrogen is taken due to the presence of triple bond. Two hydrogen atoms are added at this carbon atom and two hydrogen atoms are added at this carbon atom. So R CH2, the triple bond becomes single bond CH3. So what is the product? R CH2 single bond CH3. So alkyne is converted into alkane. Example ethyne. As I explained previously, two carbon atoms. So that is named as ethane. Since there is a presence of triple bond, the naming is given as ethyne. In presence of hydrogen, two molecules of hydrogen at the catalyst of nickel or platinum or palladium at the temperature of 523 to 573 Kelvin. Two hydrogen atoms are added at this carbon and two hydrogen atoms are added at this carbon. So CH3 single bond, triple bond is converted into single bond CH3. Ethane is converted into ethane. From alkyl halides. Alkyl halides. What are alkyl halides? Alkyl means generally represented as R, that is nothing but CH3 groups. CH3 groups are generally mentioned as R, alkyl groups. Halides. What is meant by halides? Halides are nothing but halogens. Halogens are fluorine, chlorine, bromine, iodine. They are generally represented as X. So that alkyl halides are X alkyl halide. So two molecules of alkyl halides combines with two molecules of sodium, we will get alkane. How this obtained? The halide group of alkyl halides combines with two molecules of sodium to get sodium halide compound, and the remaining alkyl groups combines together to get alkane or alkane. For example, bromomethane. So, how it named as bromomethane? Methane, since there is a presence of single carbon atom, this is called as methane. And bromine, here it is named as bromo. Halogens are named as either fluoro or chloro or bromo or iodo. So here it is named as bromomethane. Here first is methane and second is bromine group, right? So, but while naming the compound according to the alphabetical order, bromo group comes first and methane group comes second. The bromine combines with the bromo compounds of alkyl halides combines with sodium molecule to give sodium bromide, and the alkyl groups combines together to get alkane. CH3, CH3 combines together to give ethane. That this reaction is called as Wurtz reaction. That is, alkyl halides reacts with sodium in presence of dry ether. Alkane is obtained. This reaction is called as Wurtz reaction. So, a special thing here is only if the methane cannot be synthesized or prepared by this Wurtz reaction. The reason is here we have to take two alkyl halide molecules, two alkyl halides. So, alkyl halides must be, if there is a single alkyl halide, CH3X Wurtz reaction does not take place. So that two alkyl halide groups are required. So two alkyl halide groups, two alkyl groups are present. So minimum 2 means this is called as ethane. So methane cannot be prepared by Wurtz reaction. By reduction with nascent hydrogen. Before entering into this reaction, we shall see what is nascent hydrogen. What is the difference between atomic hydrogen and nascent hydrogen? So, the nascent hydrogen actually getting from some reactions. The difference between atomic hydrogen and nascent hydrogen, that is, atomic hydrogen is a hydrogen that is the stable in the atomic form itself, that does not really form bonds with some other something else, some other compounds. But nascent hydrogen is a hydrogen atom released during a reaction, and it readily reacts with some other compounds rapidly, so that it is called as nascent hydrogen. The reaction occurs rapidly, that is called as nascent hydrogen. So here alkyl halide undergoes reduction in presence of nascent hydrogen, we will get alkane. One hydrogen is added to the alkyl group, another hydrogen is added to the halide group. So RH and HX. For example, bromoethane reacts with nascent hydrogen to give ethane plus hydrogen bromide HBr. The next reaction from aldehydes and ketones. So, the functional groups, aldehydes and ketones, we already saw that. What is meant by aldehyde group? CHO group is called as aldehydes and CO groups are called as C double bond O groups are called as ketones. So, here it is a propanone compound. Propane means 3 carbon atoms. Since there is a presence of keto group, this is called as propanone. Reacts with 2 molecules of hydrogen in presence of zinc and concentrated HCl. Propane is obtained with the release of water molecule. Actually, what happens? This occurs through a intermediate process. That is a separate mechanism. I will later explain in a separate video. Similarly, aldehyde, ethanol, AL, ethanol, aldehyde means pronounced as ethanol, AL, reacts with hydrogen in presence of zinc, concentrated HCl to give ethane plus H2O. From carboxylic acid, that means decarboxylation. Decarboxylation. So here one special thing should be noted that if we want to prepare a methane, we have to take a compound with 2 carbon atoms. Because the reason is here it is a decarboxylation process, removal of carbon dioxide, so that definitely one of the carbon will be removed. So, for the synthesis preparation of methane, we have to take 2 carbon reactant. If we have to prepare 3 molecule alkane, carbon alkane, we have to take 4 carbon hydrocarbon reactants. So, here for example, sodium carboxylate is taken. Reacts with sodium hydroxide in presence of calcium oxide at 630 Kelvin temperature, alkane is obtained. How this obtained? The CO, Na, Na, so Na2CO3, sodium carbonate is removed and the remaining alkyl group and hydrogen are combined together to get alkane. So here we have taken sodium acetate. CH3COONA reacts with NaOH, sodium hydroxide. So sodium carbonate is removed and the hydrogen combines with CH3 to get methane. That's what I said. One of the carbon must be removed so that when we are preparing some hydrocarbons, depending upon that, the reactant taken should have one addition carbon atom. So here calcium oxide keeps sodium hydroxide dry in this process. So in laboratory methane is prepared by this method only. By electrolysis of sodium or potassium salts of carboxylic acid. So what does mean by electrolysis? Electrolysis is a ionic process of ionic substance which are decomposed into similar substance when an electric current is passed through them. That means nothing but flow of electrons or ions. That is nothing but electrolysis. So here sodium carbonate is taken and the electrolysis process are carried over. Since there is a presence of Na plus ion and the remaining is charges minus ion, electrolysis carried over. So we will get alkane as a product at anode and NaOH H plus and two molecules of CO2 are removed as a byproduct. Sodium acetate CH3COONA undergoes electrolysis process. We get ethane as a product and remaining NaOH H2 plus CO2 as a byproduct. These are the preparations of alkane. Thank you.